So welcome everyone to the last installment for the year in the Sculptform Speaker series. We do have one more workshop coming up in a couple of weeks' time, which will be held by our studio manager Blake, and that will be on coatings. And we are luckily able to welcome people in Melbourne CBD into the studio, but we'll still maintain our online events. So we'll get started with this one, which is on rainscreen facade design. We have some really exciting presentations coming up. So let's get started with that. So first of all, I just wanted to respect and acknowledge the traditional owners of the land and pay respect to their elders past and present. Just to give you an agenda for today, we'll give a little bit more introduction to our speakers just before they go on stage. But we have today joining us Jiulu from ARUP, Adam Pistola from Lions Architecture, Simon Frederick joining us from our Sydney team. So we'll have some Q&A time after they present. If you have questions, please drop them in the chat box so we don't miss them. I do also suggest you start your question with the first letter of the presenter so they know who you're addressing. So start it with D for D, A for Adam, and S for Simon, and that way they can spot them. After they finish presenting, they'll be able to answer those live, and we'll also have obviously a discussion in the end. If we don't get to your questions during the live presentation, we do also send an email with the answers next week, and you'll also have all the contact details for our presenters. So if you have more detailed discussion and you want to take offline, you can certainly do that. At the end of session today, we will draw out our lucky winner draw for Moda Shandong package. So if you're asking questions, that is where we draw that out from. Make sure you stay on the line when we call out your name. Just let them know you're here and we'll get an address to send it out to you. So that's all the formalities, and I will introduce our first speaker today, Jiulu, who's joining us from ARUP. Now, give you a little bit of a background on how we actually started to put this workshop together. Is we had a big meeting internally, and after about an hour's discussion, we realised that none of us could really agree on exactly what is a rain screen facade. So we thought we definitely needed to get an expert opinion to set the record straight. And I'm glad it wasn't just us. Jiulu suggested there are quite a few different sources having different opinions of what it is. So we're really glad to be able to have him jump in and let us know what it actually is. So Dee is a senior facade engineer, experienced in design and technical analysis of building facade systems, and in particular window wall, curtain wall, and metal cladding systems. He specialises in structural design of aluminium, steel, glass, concrete, GFIC and ceramic materials, and is also experienced in thermal, acoustic and waterproofing design in the building envelopes. So Dee is experienced in both prescriptive and performance-based design of facade system, and is currently managing multiple facade projects locally on a wide variety of commercial and residential projects. And Dee, I'll welcome you to share your presentation.
Oh, hey. Can you see my screen now?
Yes, we can. You're live. You're good to go.
Okay, cool. Hey, good afternoon, everyone. My name is Dee. I'm a senior facade engineer in ARUP Vic SA facade team, and I'm based in Adelaide. Yeah, thanks, Kate, for your generous introduction. And maybe let's kick off on ring screen cladding. And so today I'm going to talk about the following points from top to bottom. We're going to explore what is a ring screen cladding, its definition, build up, which is then followed by a couple real life examples. And then we're going to talk about why ring screen and what good about it, and what need to be considered when specifying ring screen cladding. Lastly, I'm going to touch base on a few commonly used ring screen cladding materials. So, firstly, what is a ring screen? To be honest with you, there's no strict definition on this, but based on our experience, our ARUP London facade team summarized the ring screen cladding as follows. So ring screen cladding is attachment of outer skin of a real ventilated cladding to a new or existing building. The system is a form of a double wall construction that uses an outer layer to keep out the majority of the rain and allow the drainage and the evaporation, and then an inner layer to provide thermal insulation, prevent excessive air leakage, and also to carry the wind loading. So as you can see in this isometric view, So ring screen system incorporates outer rigid cladding, which provides a protective barrier. So in this example, it's aluminum battens, and then a weather barrier, which is the blue layer, and in between the two is the ventilated airspace in between, and after that is a structural wall behind, which in this case is a star wall. That's to support everything. And then let's take a look at a couple examples. The first one is the ANZ house in Adelaide. As you can see from the image to the left, the lifter core and the entire western elevation are built out of precast concrete and concrete filled block wall. And an open jointed aluminium cladding is then installed afterwards to turn the facade into a ring screen cladding. As you can see to the bottom left, the aluminium cladding is the outer layer. Uh, and then followed by approximately 50 mil air gap between the cladding and the wall, and the structural wall. And the structural wall forms the weather barrier. And here's the second here's a second example, which I trust is seen very often in this country: a brick veneer wall in the residential market in the residential market. So the wall is typically made of a load-bearing brick veneer that is supported of timber steel studs. A layer of water barrier, or sometimes called sarking, is then placed in front of the star frame to form the ultimate weather defense line, as well as the vapor control. In our climate, Adelaide or Melbourne, they are often vapor permeable, that allows the moisture in the insulated area to vent to the outside. And here is a very brief history. The concept of the ring screen has been around for ages, and in the UK, the Building Research Station declared the advantage of the drained and ventilated airspace behind wall, but it took another 25 years to become commonly practiced. And in 1952, the Akua building in Pittsburgh, cladding open joint aluminium panel, is one of the first kind of ring screen cladding. And here in Australia, where we do see them being used, quite a few iconic commercial or house buildings across major cities. Having said that, though, the most commonly seen cladding type is still like face sealed cladding to medium-rise residential or commercial buildings. And so why do we care about ring screen cladding? What it matters? So next slide. I think because nobody wants to see this happen to their projects or building. So this is the office building in Queensland, and our diagnostic team in Brisbane has been called up by the client to go take a look at what happening to this one. So this one is a CFC cladding to the top of the building. It is a face sealed system. So basically what they find out on site is that the top part of the face sealed the top part of the sealant of the face sealed system failed, and the water starting to get in, and the bottom one seems to be sealed a lot better than the top, and so it's basically turned into a fish tank. And you can see they drilled a pilot hole there, and the water started just draining out. And as a consequence of this, all the steel structure behind are rusted, and the whole part that at the top of the building has to be replaced, including the steel support structure. And now let's take a look at the working principle of a ring screen cladding. And to know how it works, firstly, I think it's probably good to understand how water can get into the building. So there are three elements to a leaky facade. So driving force, water, and gaps. So the driving force can be pressure, like wind blowing on the facade, or natural gravity, or kinetic energy, which is very common, like wind-driven rain, and the surface tension capillary actions. So reliably getting rid of any one of those elements will stop the water coming in. So the externals for a ring screen system, the external skin shed most of the water and slow down the kinetic energy associated with the droplets. The vented air gap will eventually or rapidly pressure equalize with the external pressure. This depending on the open gap. The bigger the gap, the quicker it equalize. So the pressure equalize will help to reduce or removing the pressure difference. So the water is less likely to be driven into the cladding, into the air vented zone. And then the air barrier stops the external air into the building. And it is worth to note that this is also used as a vapor control layer in heat, depending on the climate. And so as I mentioned before, in our climate, like Adelaide or Melbourne, it is normally treated as a vapor permeable. So the moisture that trapped inside the insulation or the stud wall can escape out. So to stop the mold formation, and this is very important in residential buildings and health facilities. And now let's take a look at a few points that we need to consider when specifying or considering adopting a rain screen cladding. Rain screen cladding is good, but we need but the first thing we need to be mindful of is the material of the supporting frame, brackets, and the fastener. Due to its nature of open joint, the supporting frame and fixings are exposed to external atmosphere. So this is the difference between the face sealed and the ring screen open joint ring screen cladding. So care needs to be given when it comes to material and coating selection to prolong its design life against the corrosion. So secondly is the rigid and the strength of the weather barrier, which is the inner skin of a ring screen cladding. Again, due to the open nature, this layer is subject to the external wind load. So when it comes to the material selection, we need to make sure it's suitable for the location and the wind pressure of the building. So a solution in this in the Australian market to this problem of rigidity and strength is I think the James Hardy got this RAB board, which is a vapor permeable and also is a rigid board. So it's pretty good to use on commercial building. And the third one is impact resistance of outer skin, like from hail damage. So like shown on this, the cladding of this warehouse. And the hail damage is a bit random, but in cyclone region, the Australian standard has the specifications for impact testing for facade element in those areas. So the material and the thickness of those outer skin needs to be considered or tested in accordance to the standard in those cyclone area. Last but not the least, thermal bridging of through the brackets of fastening, and we're in the era of National Construction Code 2019, and the section J of the code has highlighted the disadvantages and what the thermal bridging can do to the thermal performance of a wall. And the picture to the bottom right is like a composite bracket, which help to reduce the thermal transmission. And now let's take a look at some mostly commonly used cladding material. So aluminium, the first one is aluminium. It has been used extensively given to its durability, range of color options, lightweight, and ease of fabrication. They normally comes into two forms: coil product or extruded product. With a coil product, they are typically folded into cassettes, which are then installed to the wall. One thing to consider when using coil form, the product is it's a distortion, or often which is often referred to as oil canning, and so this could result from the locking stress in the fabrication process or buckling of the sheet on the thermal expansion and contraction. So this will impact the visual appearance of the cladding. So extruded product can come in a variety of different shapes and given the designer flexibility to choose the profile they want. So another good thing about extruded aluminium cladding is that they usually come in with better tolerance than these folded coil products. So has better flatness, which could be desired, which is desired in the architectural applications. So the next one is a steel with the good old polyester powder coating on galvanized coil sheet, coil steel, which is commonly known as a color bond. The steel cladding is a popular choice in mild to moderate corrosivity environment. So they are often used in industrial buildings, and actually they're used pretty much everywhere: schools, industrial buildings, offices, and so similar to the coiled aluminium cladding, they are fabricated into cassettes or interlocking panels, like the one shown to the top left corner. So similarly, oil canning is of a concern and needs to be considered at the design stage. So the next one is terracotta. This material on buildings has been around for centuries, and they are often used as a cladding to a ring screen wall in the modern age. As you can see on the image to the right, those terracotta tiles are often made from extrusions and then heated through a continuous roller kiln to form the final product. They are extremely durable. That's a good part of it, and it probably outlasting the building itself. And lastly, of course, our timber and composite aluminum panels in a low that normally often used in low-rise buildings or interior. But one thing to mention is that they are only on external skin. They are only applicable to Type C construction when in accordance with the National Construction Code, when non-combustible cladding is not required. And yeah, I think that's pretty much it. Yeah, thanks for listening. Yep, I'll hand over to Kate.
Excellent. Thank you so much for your presentation, Dee. And I have to say, actual special thank you for dropping our images there. That's really appreciated, of course. Just get our details for our next speaker ready. And I will also mention how we selected this particular project is, again, we asked Dee, hey, do you know a really good example of a rain screen facade? And he actually mentioned Northern Hospital. So we were very much lucky to be able to track down Adam, and he's very, very kindly agreed to come and present of what a really good example of a rain screen facade is. So very lucky to have him. So Adam is a senior design architect and principal of Lions. He's specialising in the design of higher education, cultural, urban design and Justin projects. His design leadership and attention to design opportunities at all scales has enabled him to contribute across urban design, architecture and interiors. And expanding on his role in his practice, Adam also leads architecture and urban design studios at the University of Melbourne and RMIT, and is closely involved with Open House Melbourne. So looking forward to hearing Adam's presentation.
Thanks, Kate. Thanks for your introduction, and thanks, Dee. And again, thanks everyone for joining us in these strange times. It is always odd to be presenting to a screen, but it's great to see so many people joining us this afternoon. I'm going to try to share my presentation now as well. And as Kate mentioned, this is the Northern Hospital project in Epping, for those of you who know Melbourne. And it looks all like a new project, but actually it's an expansion of a project. So there's already a 3-story building on site that we've added to. And Dee's done a really good summary of the technical issues around rain screens, as well as some of the construction issues with them as well. What I really want to focus on is the opportunities for creating public architecture. We considered rain screen facades or a lightweight facade from very early on in our design process. And what I want to maybe just sort of share with you is how we use the opportunities or the design opportunities which a rain screen facade does provide to sort of change up this project, which is a very challenging health project for those of you who have worked in healthcare. There are a lot of issues to imbalance in healthcare projects. There are obviously budgets, there's the needs of building projects on live hospital sites, and this project out at Northern, it's been built by Kane. It's almost finished. It's been about an 18-month build process, and we're really looking forward to this being handed over to our clients, Northern Hospital, early in the new year. So this is one of our render images from the design stage, showing you a big green building. I'm sure it's going to get a nickname in our Epping, but the idea of being able to choose these colours and to make a project that was really, really vivid was a key part of our design process. And again, it tied into the facade materials that we chose to use. Again, for those of you who may not be familiar with Melbourne, Epping is an outer northern suburb. It's got a view all the way back to the city, but also a really great view towards the Yarra Ranges. And our project is located on the edge of the hospital site, this project here. So we're building on top of this existing building that's a couple of years old. But looking out this way from the project, you have a great view towards the green Yarra Ranges on the edge of Melbourne. And again, this is one of our early render views of the project. It does have two sides to it. We might describe it as having business at the back, but the party at the front. In terms of a haircut, it's a bit of a reverse mullet of a project. So we really did put a lot of our effort into the public face of the project. And we wanted it to be a project that was really visible from all around the suburb. This is a growing suburb. Everyone here drives by car. We wanted to have a really strong visibility, just like road signs, like this painting by Jeffrey Smart, and it does act as a key wayfinding piece within the Northern Hospital campus, which has developed from a low-rise hospital, and this is their first tall building. So we really did want to make a really strong statement for the hospital, but also right next to it, there's a shopping centre. So we're trying to, sit alongside shopping centre architecture and a hospital campus that's only going to grow over time and be more key to the community. These slides here just talk to some of our design process where we made this decision to go from what might have been in a different version of the world a precast concrete building to one that does have a lightweight rain screen facade, which then allowed us a whole range of opportunities. So firstly, we had this 3-story building that we were going to build on top of. There are other parts of the hospital which plug in to the project on the lower levels. Then we have the 4 levels of the wards. There's a canopy that comes onto the front of the project. There's a big public stair on the corner of the project. And then what we thought what would be really great with the opportunity of a lightweight facade is to actually show that stair on the corner of the project as like a key public space within the new hospital building, and then provide just really long open windows. Again, we have this great view to the hills of the Yarra Ranges to the north, and using a lightweight facade in this instance allowed us to create these long horizontal windows, which meant that we could have a little bit different to the first stage building. Rather than smaller windows in a precast facade, we could have long, wide windows, which we think would provide a really great benefit for the patient bedrooms. And it meant that, again, we could also bring in the colour scheme of the Yarra Ranges right into the interior of the hospital too. By going back to the facade, we set up this idea of the long horizontal windows. We set up this idea of showing off the stair. So you can see with those windows which fold around the corner there, coloured there in pink, that the facade, this lightweight facade can actually follow the form of the stair, which again allowed us to open up the building towards the Yarra Ranges. So when you do, step out of the lift or use those stairs, you have this really broad view out to the Yarra Ranges. And also think about other typologies and examples of hospital buildings having access to landscape, or at least views to landscape, is part of that healing process, as well as having a stair which can be used by people, not just as a transition space, but as a meeting space. But that stair is a whole nother story. We also thought more closely about the colours of the Yarra Ranges and that part of Melbourne. And there's actually a really great mural in the foyer of Northern Hospital, which really does, it really does show how connected Northern Hospital is to the outer north of Melbourne. So we did some research in terms of some of the colours from different landscapes around the project, abstracted these through a digital design process, then made it real with just using RAL, the powder coating fan deck to choose our colours, and brought it into the rain screen facade using a aluminium cassette system with the 6 different powder coating finishes. That slide snuck in there, my apologies. The other thing with the color, again, we want this to be strong, to be striking, to sit alongside things like petrol stations. So the canopy as well has the same color scheme as the facade. So again, it's like a really strong, clear marker of where the front door, so the project is. So the colors of the facade of the rain screen, they're not just on the building, they're on the canopy as well. We document our projects in Revit, and we document in colour to make sure that we can achieve all of these outcomes. We're able to document the rain screen facade as a separate trade package, pulling out each of these elements of it to allow for easier shop drawing and coordination as well. And the other thing about rain screen facades is they do sit separate to the structure of the building. So for the builder, they're able to obviously build the structure very quickly, and the facade goes in front of that. Being a rain screen, the building interior can be sealed up very, very quickly. A lot of those performance issues, which we all have to deal with now in terms of the higher thermal performance of buildings, the waterproofing requirements now we can deal much more easily within the one surface, and then there's the outer decorative layer on top of that. So showing the project under construction here, there's the concrete frame with the rain screen facade going up here on this corner here, and that's a more developed view of it back in September. And stepping closer to it, you can see the brackets for the rain screen facade here, as well as the sunshades which are integrated to it. So the other thing which the rain screen facade allowed us to do, it was a little bit easier to integrate the sunshades as part of that facade. And again, we had so much liberty in terms of the shapes that we were able to make in a non-load bearing rain screen facade, as well as integrating sunshades and obviously all of the colors and finishes that we're after for the project. Again, going from render to what's been built, we're really happy with the outcome and the strength of the colors and the clarity of it. And that's a shot of the project under construction, almost finished from about 2 weeks ago. So we're looking forward to seeing it finished. And again, making a decision early in the design process, tying it to some of the vision for the project to be a really strong urban project, to be a strong piece of public architecture, allowed us to get to this outcome at the end of the day. So thanks everyone for joining us. Happy to take any questions.
Thank you, Adam, and I really enjoyed you giving us the backstory of your design methodology and how you what you consider in designing facade. That was really informative. Just with questions, just to remind you, if you have any, if you could drop them into the question tab, so our presenter Adam and Dee can take them now. If you start your question with the first letter, so they know which one to attend to, they can answer them live, and we'll also get to them in the discussion. And now we're going on to one of our own. So Simon is our project manager in our Sydney team. So Simon has been with us for the last 2 years, and I mentioned some of the key projects that he actually led, but he's actually been installing facades for the last 25 years. So he has a lot of hands-on experience in terms of what actually happens on site and what sort of issues you come across when you are installing facades. So everything from high-rise buildings, from small single-story buildings that he has done. And in the past, some of the key projects he managed in Sydney while with Sculptform is Arcadia Apartments with Dico and Breeze Architecture. I could see his smile lead up there when Dee put up the picture. Clearly a project very close to his heart. And he's also very much involved with our product design team for rainscreen Facade Design. So he's very passionate about the subject, and this is why we gave them the spot to present the products in the development. So I'll let Simon take over from here.
Thank you, Kate. The very kind words in the introduction. And again, thank you to everyone for your attendance this afternoon. As Kate touched on, I've been involved in facades for quite some time. Most of my time has been spent installing them. I've got extensive experience in aluminium composite panel, or ACP, Vitropanel, 9mm CFC, and terraçade formats, just to name a few. The work has ranged from high-rise commercial construction in Sydney CBD, as seen by the World Tower there, and single-storey houses in suburbia. Rainscreen facades are something I've spent a fair bit of time on. Having installed a lot of them, I understand the challenges and requirements of the install procedures. Getting involved in the design and the development of our rain screen system has been really challenging and rewarding. At Sculptform, we design lining systems for walls, ceilings, and facades. We work closely with architects and builders who use our modular systems to meet design intent whilst remaining buildable. We were consistently asked for more coverage with our current facade system. One job in particular, this one here, was shown as a catalyst for us to develop another product to suit such requirements. Hassles with the architects on this one, and they were looking to meet a solid wall design with minimal texture. We couldn't use our timber cladding boards due to the fire requirements, so the solution was a 100mm wide aluminium batten with a very small gap. This highlighted the need for a fire-rated system. A click-on cladding has been developed over the last 2 years at Sculptform to meet this need. So we started to develop the click-on cladding system to address these questions and to help architects who are looking for a highly customizable bespoke rain screen solution. The system utilises a clip and track platform with an aluminium extrusion. It's a lightweight modular system that can use a wide range of profile suites that, when combined, will give depth and contrast to any surface. It's also non-combustible according to 1530.1. So click-on cladding utilises our proprietary mounting track system, which can be fixed to virtually any substrate. Once the tracks are installed, the boards simply click into the clips, allowing for speed and accuracy in the installation process. We have a range of cladding profiles available that can be combined into any sequence, ranging from fine clean lines to bold shapes. Different textures can be created using shadows and differing depth profiles. The system also has an element of curvability built in, with both convex and concave curves possible. It can also run in most planes, with the vertical and horizontal being the most common. We do, however, have the ability to run it as an angled texture as well. The system doesn't require any specialist trades. Any carpenter can do it. It is a fully engineered system. We are currently working on a table for wind loads, which, when completed, accurately guide you to the required track spacing necessary to achieve the loads on your specific project. It can come with all trims and angles required for the install, or we can help configure custom connections to your existing substrates. Overall, it's a quick, simple, and cost-effective method. I'll show you a short clip now to show you just how simple this thing goes together. Okay. So here you can see David installing boards. It's sped up slightly, but it's simply a matter of engaging the tongue and groove and tapping the board in place to set the clip. We also have a click-in angle trim to complete the works. So as you can see, it's quite simple. Its applications will include facades, soft elements, interior to exterior transitions, and curved walls and ceilings. So we have a range of profile suites available. They come in various shapes and sizes. The panel suite has been developed to use in place of aluminium sheet cladding. We have extrusions offering different widths and can adjust the spacing between the boards to achieve a zero gap with that subtle flat texture. It's an extruded product, so it's more durable than the roll-formed alternative, which means it won't oil can in the sun. Oil canning happens to roll-formed products when they heat up. The material expands, causing an uneven surface. I believe Dee touched on this earlier. In my experience, moving materials around site, especially large sections of ACP and CFC panel, is problematic. Lifts are usually very small, and not all jobs have access to internal or external craneage. Cladding boards would be easier to move around as they are lighter, narrower, and therefore less prone to damage. During the process of installing facades, it's often access that's limited. Moving large or heavy sections around was always painful and awkward, at the risk of damaging the product or even yourself was always present. We have a range of 3D suites as well. They consist of a single flute profile, which has two widths shown, the 75 and the 120mm board. We also have a double flute profile, which is the 60mm board size. We have some in development as well. So this is being developed for architects that want a completely bespoke system. It gives the flexibility to combine different profiles and board widths to give bold, rich textures. There's a 50mm block profile, which consists of a 50mm block and a 50mm space to give the look of a batten, but have the benefits of a rain screen facade. We also have the edge profile suite, which is designed to look like standing seam. And as you can see here, you can add flat boards to create textures and different tones. This image shows just how configurable this system is. You can combine profiles from any suite in any sequence you can think of. As the system is built on the same foundation, it truly is just the board that needs to change, giving you the ultimate in rain screen configurability. We also have the option of custom shape profiles using the same click and track foundation. Shown on screen is our wood finish aluminium. Ideally, the use of solid timber boards is preferable in soffits and walls. However, with the current fire regulations, it's not always achievable. We have tried to give the architects and designers the most realistic, non-combustible timber cladding alternative available. To achieve this, we sent some Australian hardwood timber samples to Japan. They've come back with what we believe is the most realistic colour and grain profiles in the market today, as you can see here in the comparison showing real black butt timber against the wood finished option. Our wood finish aluminium is more realistic than the powder coat alternative, and in comparison has an excellent resistance to fade. It's also backed by the 10-year warranty. So to finish off this presentation, I'll show you some photos from Folio Apartments. This is currently being installed in Melbourne, and it's a 150mm board from the Timber Look aluminium suite. As you can see, there's track and boards. It's a very clean system, and it's serving the purpose in a Safed. So that's our system, and if you'd like any more information, please contact us.
Thanks, Simon. Now I'll just close this down so we'll all come on screen. I know there's a few questions that have come in, and I think all of our speakers were way too interested in actually listening what was going on the screen rather than answering questions. Now, I know this question comes up all the time, which is one of our hot topics, which is fire. I'm not sure, and this will probably apply to all the speakers, especially Adam and Dee. So Chris was asking, how's fire separation between levels addressed when using lightweight rain screen facade systems?
Yeah, fire. Maybe I will give a shot, Adam, if you don't mind. Yeah, so yeah, lightweight ring screen cladding and fire separation at the slab. I think one way, this is a couple of ways to achieve them. One way to do that is use your slab and to build your, the solid wall, the partition wall needs to be fire rated, and the built-in board of the slab. So the front of the wall is flush with the slab, and then you have your ring screen cladding to the front of it, so the fire then can't pass from the level below to the level above. So that's one way to do it, and I believe that's what's done the Northern Hospital, wasn't it? Yeah, and another way was to build the framing continuously, but then there needs to be like a special fire treatment and a spray between slabs to achieve the same performance as the slab. So those are the two that I know so far. Yeah, which I know a bit more about fire. Yeah.
Adam, did you want to comment on that one? Are you happy with Dee's answer?
No, that's perfect.
Excellent, covered that one. Now, another hot topic that we have, obviously sustainability is a big hot topic for everyone. Amber's asking, they're interested in the panel's knowledge in the embodied energy in the different types of rain screen and the benefits in passive house design.
I've got one for you, Dee.
Okay, that one is a hot topic. Embodied carbon energy. it's a very tricky process. And to be honest with you, I'm currently working on another project in Adelaide that we are compiling information on that. So yeah, between aluminium and terracotta and steel. Yeah, so I haven't got to be honest with you, I haven't got a detailed like data in front of me, but based on the like fabrication, like, but we can maybe this all goes back to like how they were made. Like terracotta, they basically just dirt. They got dig out from the ground and molded into shape, extruded into shape, and then fired at 1200 degrees for a few hours, and then that's it. And aluminium, you have to firstly get the aluminium ore from the mine, and then transport that to the facility where you turn that into the raw aluminium like billets. And then that get heated up to a 500 degree and then pressed over these dies or rollers to make them into coil or extruded products. And then after that, it has to be like heat treated to gain its strength. So yeah, so similar process applies to steel as well. So yeah, so I think to work out like embodied carbon, we need to look back into the manufacturing process. Yep. Yeah, but on passive housing, I don't think embodied. I'm not sure if embodied energy is part of the design criteria, because I'm just looking at this Australian Passive Housing Association. There's the 5 design principles are air tightness, thermal insulation, mechanical ventilation, and high performance windows, and the thermal bridge free construction. I think yeah, rainscreen cladding designed properly can address all these concerns. Apart from the high performance windows, you need to check in high performance windows and deals with the junction carefully. Yeah, that's pretty much it.
Yeah.
Thanks, Jay. I just want to say, sorry to jump in, Adam. I love your common sense approach. You know, when people ask for ratings, we all want to see numbers and formulas, but sometimes it does come down just kind of having to think, well, how do we actually make this material? And that's an easy way to work out what's actually better to use. Sorry to interrupt.
It's okay. I was just going to add to Dee's comments about the looking towards passive house systems being able to really seal the facade. I think rainscreen facades will definitely be part of that that solution going into the future, where you can really seal them and you can also deal with the thermal bridging challenges. Because I think that those images you showed, Dee, of how fixings impact thermal bridging, even how sunshades impact that. You know, these kind of systems do provide some ways around some of those challenges.
Also, have a question in terms of the types of projects where rainscreen might be a better system, or where it's a system that you maybe go with the different options. Can you give us some examples of that? You can all answer. Don't fight.
I think from our perspective, there's it's what's going to make the best bit of public architecture. You know, sometimes we do want to have projects that talk to the context in one way. Other times it's about a different connection to the place, which a lightweight facade would allow us to do, and that's always balanced around the expediency of the construction process. And in the case of Northern, you know, being able to bring in a prefabricated facade that had a complex geometry into a complicated construction site, it was easy to do as a lightweight system. You know, again, allow them to seal up the interior quickly, and then the architectural layer comes later. There are benefits to it. Again, it might not have been possible in a precast facade to get the same outcome. So just about balancing, you know, what do we ultimately want and what's the best way to achieve that.
And could I just ask on that, so in terms of actual materials for the finish, how many options did you consider?
Well, going back to the issue of fire, there are, you know, at the time that we designed it, you know, pretty limited options. You know, we only use solid aluminium on our projects. These are, as I think, you know, everyone in the industry does, or a color bond. We do avoid any composite systems now. So there weren't too many options. especially probably in a facade that's more affordable. You can obviously go to a curtain wall, but that does bring other costs with it. So this is another more and more affordable option as well.
That's a good benefit to bring up. I don't think Dee covered that one. I think just focus on a more practical one, but budget is another big issue that we'll have. I'm just going to shoot it over to Simon in there so he doesn't quite fall asleep on our presentations there. From your time being on site, can you give us, from a practical point of view, from different facades, what sort of issues can you run into on site from installation point of view?
That's a that's a long-winded question. Well, it could be a long-winded answer. Access seems to be one of the biggest things. Obviously, working on the outside of a building, you have a lot of contributing factors with regard to what you can actually fit and what you can move through the build as well. I have worked with Uanda in the glass and glazing side of things, and moving curtain wall around is extremely problematic. So hence why it's done first. But composite panel, well, we used to use a lot of composite panel. It's a lot of folded aluminium sheet now. Terracotta tiles, so terracard, for example, that's it's also very heavy to move around. You can't tend to stack too much material. If you're using EWPs or limited access points, it's very hard to get stuff around. I would say access and not being able to get back to it to fix anything. You get one shot at it and then the access goes, especially in the case of like a jump screen, which moves every 3 floors sort of once a week. So you, access would be the biggest thing for me, I reckon.
Excellent. And again, getting back to that common sense, which is really important. The next question, which I'm kind of going to combine two together. Somebody was asking about the recommended minimum cavity side. So I'm expecting it's between the actual rain screen and the backing. And then the other question, I'm just going to roll it into one, was how do you deal with vermin control in the void space?
Yeah, that's $1 million question, to be honest with you. Yeah, the cavity size, it's really depends, I think. It depends on whether you want to achieve like a full pressure equalized like cavity or partial pressure equalized cavity. And to be honest with you, there is a design guide on calculating the gap you need to be able to achieve this. But I can't remember those equations. But generally, like 50 mil is a good hands-on approach, and 50 mil, yeah. And it varies depending on really what you want, and that can go into quite more detailed discussion depending on the real application. Yeah. And vermin control. I'm not sure whether these spiders are really like to going there, because that could be pretty hot in a summer day. And I to be honest with you, I haven't noticed that issue. This NZ house building, I went there, took a few photos of the cladding. I couldn't see any. I couldn't see anything behind there. Yeah, their open joint is about like 25 to 30 mil. Yeah, I'm not sure if Adam has anything or Simon has anything to add on this vermin topic.
I think from a design perspective, tolerance often comes down to technique. What tools are being used to install it. Does someone need to get their hand in to adjust any of the fixings? How the different elements slot onto brackets. If those get closed up with a different installation method, you do reduce the chance of vermin getting into it, and you do increase that, sharpness of the appearance of the facade. So it's good to see new systems coming onto the market, which do look a lot sharper and don't have those larger open joints, which maybe some of the earlier systems had in the rain screens.
Thanks, Adam. And that actually ties into somebody was asking, like, what are the benefits of the click-on system compared to standard cladding system? So I think that sort of ties into that question of gaps. So I'm going to pass it on to Simon.
Yeah, okay. I think the click-on system is going to be easier to install. It's a lighter weight system than some of the more traditional ones. Being that the panels are narrower, I think it'll make it more modular, so you'll be able to move things around easily. Stacking material is going to be easier because it'll take up less space. Look, I think it's a solid connection. It's an engineered solution. It's fast to install, and I think it just gives you a really clean line. So I'm also a little bit biased. So
that's all right. We'll forgive you just this one time. This is taking a question a little bit broader, and it was very interesting for Dee to mention that we needed to consider for hail damage on cladding systems. So if we take sort of broader approach on international scales, are there major differences what we need to account for more in Australia that other countries may not need to pay attention to in terms of facade design?
Yeah. I mean, yeah, depending on how severe the environment is, I suppose. And in Australia, I noticed it could go quite extreme. Same as like Florida in the US. Yeah, in those like this roller coaster areas, in terms of weather, yeah, it's worth to give a consideration. And the common way to deal with the hail damage, it comes into two forms from the cladding. For example, using aluminium or steel, thicken up the gauge always helps to reduce the chance of the cladding getting dent. And another one is coating, and specific coating with scratch resistance or impact resistance could help on that as well. Yeah, and to go back to the question, yeah, it's really depending on the environment, and I think in Australia, yeah, it's probably worth to give it a consideration. Yeah.
Adam, did you want to chip in from your perspective the differences that we have for facade design in Australia as opposed to other countries?
Look, it's always hard not to look at places in Europe where there's I guess more of an advanced approach to some of the facade systems, but I also look at their architecture and I think, is it as playful? Is it as interesting? Is it as connected to a place and to different cultures? And I'm not sure. I really like what we do here and what we can achieve with our building systems and with our industry. So it's great what they can do there. We often do sort of joke about Swiss architecture in the office, but we think we do great architecture here, and we can learn a few things, but there's great things that we can achieve with our industry here all across the country.
Well, I'm sure there's not a lot of projects that can compete with a mullet on the back in terms of facade.
At the front, it's a reverse mullet.
Oh, in the front, yeah. No, that's definitely unique. That's a standout. Simon, did you want to comment on that one?
No, I think it's been covered. I mean, Australia has quite a variety of climates. I mean, you look up north with the cyclone season. I've put cladding on buildings in Townsville, and the requirements for that were quite intense compared to what it is in Sydney. But we don't get snow loads. Obviously, wind loads and thermal problems are probably the biggest ones we have to deal with.
Yeah, I think that's right. I think we're kind of lucky here that our environment is like in winter we're not that cold in winter, and like the Europe countries, the thermal bridgings, they have addressed those quite a long time ago, and but it's very pleased to see that our national construction code starting to catch up and realize these issues, and it's just going to make things better and better, I think. Yeah, but it does take time and steps. Yeah.
Excellent. Well, I think we're getting nearly close to the finish line. I just want to ask, does anyone have any closing comments before we draw our winner for the day? I'll take it. That's a no. So I'll just share that. Now, from people asking questions, if I call out your name, make sure you let me know that you're here in a chat function. We'll grab your details later. I've got Christopher Wyatt. And while Christopher's hopefully jumping on the keyboard and letting us know that he's here, we also have some contacts up for our studio. So obviously the main number if you do have any question for Sculptform. For studio visits, which is now open, it is by appointment, but Blake Proud is our studio manager. And if you have any ideas for events or you'd like to collaborate with us in the future, that's myself. Christopher, yes, just in time. Excellent. So I'll send you through an email and grab your details and get that mentioned and package out to you. And I just want to extend a big thank you to our presenters today. It's been a great presentation, and we look forward to seeing you in the studio hopefully sometime soon. Thanks, everyone.
Thanks, Kate. Thanks, Simon.
Thank you,
Cheers,
Kate. Thanks, Adam. Thanks, Simon.
Thank you, guys.
Yeah, have a
Thanks
good day.
for your
Enjoy the nice weather.
help. You too, mate.
Yeah.
Cheers.
Bye. Yeah.
Thanks.
Bye-bye.